for this. All right, so this is going to be objective 1. We are going to evaluate algebraic expressions using the order of operation. What's an objective? Something you want to get done, something you hope to accomplish, okay? So today we are going to evaluate algebraic expressions using the order of operation. Stuff you've already done. We are in the intro to algebra. This is 5th, 6th, and 7th grade review. Here we go, okay? Anything that I put up here needs to be written down, so make sure you get it down, okay? Anything that I write, I might ask on a notebook quiz, please write for me objective number 1. Does that mean to write the entire set of notes? That means to write just what the goal was for that day. The goal for today is to evaluate algebraic expressions using the order of operations, okay? I might even ask, please write for me example number 2 from objective number 1. So when we get to example number 2, you need to make sure, does it help you when you get home if all you write down is the problem and the answer? No! You need every little step so that you can follow it, so in case you're confused when you get home, you can follow through it. Okay, so just make sure you write everything down. Just before I forget, basketball, what time are y'all leaving? 3:15? Middle school? I got a middle school girls. I did not get a middle school boys. But you're going with them. So 3:15. And everybody's 8th grade, right? Middle school.
I thought we left at 3:10.
I got an email that said 3:15. Is that good? Okay. But nobody's JV? Everybody's middle school? So what time do you leave? Okay, because you're home. Okay. Just got to get straight who plays what, when, where, and how. Okay. So here we go. 3:10, 3:15-ish. All right. Order of operations. So we know order of operations as what? It says order of operations. We know it as PEMDAS. Please excuse my dear Aunt Sally. Okay, and I'm going to refer to it as PEMDAS, but I'm going to kind of expand on that today. In elementary school, what did P stand for? Parentheses. Well, in algebra, it's going to mean a lot more than parentheses. What else is it going to mean besides parentheses? What other kinds of things hold numbers together? Symbols. Brackets. Keep going. Them curvy things that we hate to draw, right? Those sets. I agree. Okay, sets, brackets, parentheses. Keep rolling. There's more. How about absolute value marks? What do absolute value marks look like? Them stick-looking things, right? The absolute value of 3 is 3, because it's how far it is from 0. 3 steps, right? What if I'm at -3 over here? How far to 0? So the absolute value of -3 is 3. We know absolute value as being always positive. Okay, so you got absolute value marks, you got brackets, you got sets. So I'm going to explain this more like this. So instead of just P, we now have grouping symbols. So we have parentheses, we have sets, we have absolute value, we have brackets. We also have, what are those called? Square roots. And the actual name of the symbol starts with an R? Radical. Very good. These are radicals, okay? These are square roots, and even a little bit later on in this class, we are going to look at symbols that look like that. Anybody know what those are? Those are radicals. These, when there's no number, it's understood to be a square root. Otherwise, if it has a number with it, this is called a cube root. Does that make sense? Okay, so any type of symbol that holds something underneath, I would even say the division, the house, you're going to work that first. So any type of symbol that holds numbers together, you're going to work those first. E does stand for exponents. I always love this. Somewhere in the 8th grade, there is a student that will look at me and say, Miss Corns, you always multiply before you divide because it's my dear. And my comes before dear, and so multiplication comes before division. But smart students will tell me it don't matter. They're not really one before the other. They're on the same level. It just depends which one comes first from left to right. So I put those together in step number 3, and then our add and subtract is step 4. Okay, from left to right. Okay. So again, I'll call it PEMDAS because that's what you're used to, and I'll refresh your memory and be like, don't forget to use your rules, your order of operation PEMDAS rules. But do realize it's not just parentheses, it's much more than parentheses. Any type of grouping symbol. Everybody okay? Can I go? All right, so let's start with example 1. So the first day of notes, I got to kind of lay down some rules. So here's what I'm going to tell you. I know some of you, but I do not know your math skills. I don't know the math side of you. So for now, how many of you will admit you could do this in your head? Piece of cake. Okay, hopefully most of us or all of us could do this in their head. And I trust you. I promise I trust you. But for now, I'm going to ask you, I want one step at a time. Okay? I don't want you to do any more than that for now. Once I get to know you and once we get rolling, then we can start skipping steps. But for now, I want one step at a time, and I want to see all of your work. Okay? Does everybody understand that? For now. Okay? So here we go. Do we have any grouping symbols? No. So then we go to exponents. So 2 squared is 4. Everything else comes straight down. Okay, then comes what? Divide. So 8 divided by 4 is 2. Do we add? Do we subtract first? You sure? Doesn't it? Please excuse my dear Aunt Sally. Add, subtract? When we add first? Because it goes from left to right. Prove me wrong, and I'm going to do that a lot this semester. Okay, you argue back with me. Okay, then I know you really know what you're talking about. 16 minus 2 is 14, and 14 plus 14 is 28. Any questions on that? I always start you out easy. Most people get to the examples and they go, is that it? That's all we have to do? Well, we've only done example 1. We got more to do. So here we go. Let's look at example 2. All right. What's different about this one? Say that again. There's some fractions and some decimals, so we're going to review our rules for fractions and decimals. Here we go. Where am I going to start? Parentheses. There we go. So how do I subtract decimals? We are first going to take 10 and make it 10.0, and then I heard the keywords, line it up. Always line up your decimals. So when I borrow here, so 10 minus 4 is 6, 9 minus 6 is 3. Some teachers expect you to be able to do mental math. Miss Corns would rather you be sure of yourself, and I'd rather you write it down. Okay, I'm totally okay with that. So I'm okay with you either going off on the margin of your paper and showing me doodling all kinds of little scrap work, or do I have anybody that would like kill because you like yours so neat and organized? Anybody like that? So if you want yours neat and organized, then I would have a paper for your work, and then I'd have a scrap paper for all your doodling. You with me? So I don't want you to don't sit there when I say, what's 10 minus 6.4? And y'all go, I didn't write it down. Work it out. Does that make sense? Don't do it in your head. Write it down. Okay? What comes next? Division. Okay. So I'm going to come over here to the fraction side. First of all, what do I need to do to 2? 2 over 1. And we've talked about this. How do we divide fractions? Copy, change, copy, change, flip, keep it, change it, flip it, multiply by the reciprocal, all the same. Okay? Keep it. Change it to Multiplication, and then flip this to become 1/2. Do you have to have common denominators to multiply? No. Thank goodness, right? So you can just multiply across. What will it become? 1/8 plus 5 times 3.6. Now what? Let's multiply. Come back to the decimal side. 3.6 times 5. How do I multiply a decimal? You multiply like normal, and then you just count your decimal places. How many decimal places do I have this time? 1. Okay, so 5 times 6 is 0, 30. So 5 times 3 is 15, 18. How many decimal places? 1. 18.0 is the same thing as 18. Okay. So how do I now add 18 and 1/8? What do I need to do to 18 first? 18 over 1. And then to add fractions, we must have common denominators. It's much more fun if you say it really fun. Otherwise, it's just really bad and boring and common denominators, you know? Common denominators. Okay. Maybe it's just me. So what's my common denominator going to be? 8. What do you know about the first fraction? Stays the same. How did I go from 1 to 8 here? I times by 8, and whatever I do to the bottom, I must do to the top. So tell me, what's 18 times 8? You work it out. Try one more time. Close. Work it out. 18 times 8. Carry. Who said 144? Very good. 144. Okay. It is right. 144. Okay. And then from there, when we add it together, what do we get? 145. So be careful. I had some people earlier today. They wanted to take 8 and 8 and make what? 16. But when you have common denominators, you add the numerators and keep the denominator. Now my question is, am I done? Do I need to change it to a mixed number? You are so in luck. Here's the good news. You can leave it just like this. And everybody says, but Miss Corns, when I was in elementary school, they made me change it to a mixed number. That's because in elementary school, you were learning how to go from improper to mixed, and so they made you keep going back and forth so you would know how to do it. You with me? But I know that you know how to do it, right? So I'm just going to let you leave it like that. In algebra, you'll want your answer in pure fraction form, even if it's improper, as long as it's what? Simplified. How do I know if this is simplified? You ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, ready? We don't need to check ones, because that's not going to help us. Divisible by 2? 8 is, but is 145? No. How about 3s? Does anybody know the shortcut to see if 145 is divisible? What's the shortcut, Garrett? You add the digits. Y'all remember that? And what do you get? 10. Is 10 divisible by 3? So that doesn't, not divisible by 3. Do I need to check 4? Why not? Because you've already checked 2. And if it's not divisible by 2, then it's not divisible by 4. How about 5s? End in 5 or 0? That don't work. Do I need to check 6s? Why? Because I've already checked 2 and 3. Isn't 6 divisible by 3 as well? So it doesn't work for 2s or 3s. Check your 7s. 8 divisible by 7? No. How about 8s? Can you check it? You've already done 2 and 4. Do you check 9s? Because you've already done 3. Do I check 10s? No. So here's what I'm saying. Check your 2s, because you don't have a calculator, so I'm showing you. You check your 2s, your 3s, your 5s, and your 7s. That's pretty much going to hit you, most of them. Okay. From there, what might be the next number that I might would check? Twos, 3s, 5s, and 7s. You don't need to check any of those others because 2s, 3, 5, and 7 cover them. Well, is anything divisible by 11? So you might check 11. How about 12s? Would you check 12s? No, because that's covered under 2s and 3s, right? Okay, would you check 13? You know, you could, but you wouldn't need to. I would say most of the time if you'll check your 2s, your 3s, your 5s, and your 7s, you'll know if it can be simplified or not, okay? 2s you know because even. 3s you can do the add the digits trick. 5s end in 0, 5, and then 7 you actually just have to see is it divisible by 7. But if you check your 2s, your 3s, your 5s, your 7, most likely, not always, but most likely, if it can't divide by any of those, then you're done. Okay? And you can leave it just like that. It's fine. I know it's weird. You'll get used to it. Okay? All right, let's look at another one. All right, the question of the day today is this. Ms. Corns, how do I know whether to put my answer in decimal form or in fraction form? So here's what I'm going to tell you. When you see decimals in the problem, then I want the answer in decimal form. When you see fractions in the problem, then I want fraction form. What if I see both or I don't see anything and it comes out weird? Do I want decimals? Do I want fractions? Which one would I rather have? I'd rather have fractions. 99.9% of this class will be dealing with fractions. Okay, someone said, but decimals are your friends. And I said, I know, they are your friends and you can deal with them, but fractions are better for Algebra 1. Okay, so fractions will be 99.9% of this class. So fractions trump everything. The only time you deal with decimals is when you see decimals in the problem. All other times, fractions. Does that make sense? All right, so we're going to be dealing with decimals here. How do I know? Because there's decimals in the problem. Okay, so what's different about this one? You may have already said this. It's got brackets and parentheses. So you can look at this like an onion, okay? And you got peelings, okay? First of all, you have the outside, where the 6 is. Then you've got inside the brackets. Then you go even further, you got inside the parentheses. So you're going to go to the very center first. The very center is going to be inside the parentheses. So when we add 2.3 plus 3, what do we get? Everybody okay with 5.3? You're going to make this 0.0. Okay, line up the decimals. Will I subtract? Will I square? Subtract or square? Square. Okay, so 5.3, is that 5.3 times 2? 5.3 times 5.3? 5.3 times 5.3. How many decimal places will I have this time? 2. Good, you figured it out. What do we have? 28.09. Agree or disagree? 28.09. Check this out. 3 times 3 is 9. This is 15. Then we need to lay our golden egg. I don't care whether you say that or not, but put your 0 in. 5 times 3 is 15. 25, 26. Then we add it all up. 0, carry your 1. That makes 8. Then we have 1, 2 decimal places. Everybody okay with that? Speak now, forever hold your peace. Yes? So 32 minus 28.09. When do we round in a problem? Should I round that off? Make that 28. When do we round? This is very important. When do we round in a problem? Never in the middle. Because why? If I rounded this right now, what would happen? It's going to change my answer. Okay? Does that make sense? It's going to change your answer. If you change it in the middle of the problem, then you're dealing with a different kind of number. Even though it's similar, it's still different. The decimal places are different. Okay? So it'll change your answer, and sometimes by a lot. So don't ever round in the middle. When do you round? At the end. and you just follow the directions either that I give you. And I'm going to tell you for today, I just don't want you to round, period. Okay? So just write down whatever you get. And it's not going to be anything huge. It's going to be a couple of places. Does that make sense? So just keep it as it is. All right. When we subtract, what will I do with 32? Put a decimal, put 2 zeros. So 32.00 minus 28.09. Borrow. 10 minus 9 is 1. 9 minus 0 is 9. I'm going to have to borrow again. 11 minus 8 is 3.91. And then finally, what will I do? I will multiply. So you do it. Multiply 3.91 times 6. How many decimal places? 2. Okay, let's check it and give everybody a chance. $23.46. Good set. And I would just leave it. I wouldn't round that off to 23.5 or anything like that. Just leave it till I tell you to. Okay? Any questions? Everybody with me so far? Okay. Sometimes brackets are used. Yes, brackets and parentheses are the same thing. In this case, they put brackets and then parentheses so that you could easily, it's almost better to put the like when you have two sets, if you have parentheses with parentheses with parentheses, sometimes it's hard to know what parentheses goes with the parentheses because there's too many parentheses. You with me? But so the only thing they use brackets for is to distinguish this goes together, the brackets goes together, and then the parentheses goes together. They're the same. Yep. All right. What's different about this one? It's a fraction. Yes. So how do we work fractions? Just covering our basics. There, Julie, go. You work the whole top, and then you work the whole bottom, denominator, and then you divide or simplify. Very good. So 2 cubed is? Oh my goodness. Are we sure? Rethink. Let's make sure. Everybody get on the same page. 2 times 2 times 2, right? 3 times. 2 times 2 is 4. 4 times 2 is 8. Okay. Everybody with me? Okay. All right. 8 minus 5 is 3. And 15 plus 9 is 24. Okay. Then from here, we're going to, I would rather, if you divided, you're going to end up with what? A decimal. But what do I want? How do I know I want a fraction? Because the whole thing's a fraction, right? Remember, I always want fractions. Miss Corns loves fractions. I love fractions. I really do. Okay? Always deal with fractions. The only time I deal with a decimal is when the problem's in decimals. Okay? So I want a fraction. So I would rather you simplify. Now, I would love to hear someone tell me the incorrect answer and someone to tell me the correct answer. Let's see which one we get first. Who wants to try me out? I hear 8, 1/6, 1/8. So I hear 8 and 1/8. The question is, are they the same or are they different? They're different. 8 is like saying what? 8 over 1, and 1/8 is like 1 over 8. Okay, 8 whole would be like eating 8 whole pizzas. Who could eat 8 whole pizzas? I got a couple take. Who would like to try to eat 8 whole pizzas? Right now, let's go to Tony's. Okay? All right, just kidding. 1/8 is different. It's like taking one pizza, splitting it into 8 pieces, and taking one of those 8 pieces. There's a big difference, right? One of them's going to make us feel really, really sick, and one of them ain't going to fill us up at all, right? Okay, so there's a big difference in 8 whole pizzas and 1/8 of a pizza. So be careful. I caution you on this. Just because you see 3 and 24 and you think 8, be very careful. What's the actual, this divides by 3, this divides by 3. 3 divided by 3 is 1. 24 divided by 3 is 8. So it's 1/8. Okay, so if you put 8, I count it wrong. So I caution you on that, okay, when you simplify. Questions on that? Just so you're wondering how many more of these we got, 7 total. So we got 3 more. Okay, we're getting there. What's different about this? It's got some variables in it and some numbers. How many of you, when you look at this, it looks very overwhelming? Okay, so I got some. So here's the thing. Let's decide. I hope y'all don't mind. I don't have a clock in here anywhere, so I'm going to keep time with this. Where's the actual math problem? Everything that is before the if, okay? So here's what I want you to understand. Don't let something like this be so overwhelming to you, okay? Here's your problem. What's all this stuff? This is just the information, the key, telling you what to plug in for what, okay? So my question is this a decimal problem or is this a fraction problem? So then I want you to work with it as decimals, okay? So when we plug in, how do we plug in? Like, for example, let's start with the 4 for the x. When I plug in 4, do I write this?
3 times 4.
Okay? And you write 3 times 4. Now, I know some of you are working ahead of me. Slow down because I have some rules. Okay? Can I tell you my elementary, middle school, and high school math story?
Yes.
Okay. The question is, I do agree, 3 times 4, right? We all know it's not 34 squared. It's 3 times 4 squared. Okay? But the question is, how do we write it? And how do I want you to write it? Okay, so when you were in, let me just go with this. When you were in 3rd grade, how'd you write times?
X.
With an X. And we know not to do that now because we have variables that are X's. Okay? Then you went to middle school math. Okay, 5th, 6th, and 7th grade math. So, how did you write times? With the dot. How many of us are used to the dot? You are now in high school math. How do we write times?
With a asterisk.
With parentheses. So here's what I'm going to tell you right now. And somebody in second block said, Miss Corns, this whole parentheses thing is really throwing me off. I like my dots. And I'm okay if you use the dot for the next week, 2 weeks, but I really want you to try to transform yourself because before long we won't be using dots, we'll be using parentheses. Okay? And how you write a problem is everything. Okay? Especially when our problems get a lot bigger than this. Okay? So I'm going to use parentheses. And notice what goes in the parentheses. Only what? Only what I plugged in for the variable. So if you wanted to, like I could put parentheses, so the 5.2 is going to go in the parentheses. That's it. Okay? Same thing here, parentheses there. Okay? Only what you're plugging in for the variable. Okay? So 2 parentheses 5.2. And here's where, is it Faith that asked me, where you get lots of parentheses going and it almost looks confusing because there's so many parentheses. Okay, and I agree. Notice what do I do with like my grouping parentheses? What did I do with them?
Make them bigger.
I made them a little bit bigger. Okay, if I wanted to, what could I have done with them? I could have made them into brackets, just so you knew that those go together. So here's my first step. Grouping symbols. How many grouping symbols do we have up there? How many actually groups stuff together? Here's my question. Does this group anything together? No, this is just for what? To separate and to mean multiplication. Okay? What about this one? No, that's separate and multiplication. What about this one? Separate and cube it. So here is there's only one set of grouping symbols. Okay, so that's where I'm going to work first. Multiply, add, cube. What am I going to do first? Cube. Exponents comes first. Okay, so my other question is, am I going to do 0.3 times 0.3 times 0.3 all at one time? I'm only going to do 0.3 times 0.3, get an answer. Then what? Then the answer times 0.3. So you do it. I want to see if you can work out 0.3 times 0.3 times 0.3. Matthew, it's coming your way. You got it? Okay. What's he got back there? What you got? 2.7? Agree or disagree? 0.08? 2 zeros. 0.008. 0.027. Do you hear anything you like? You like this, Julie's, right? So you got one take, you got Dylan. Taylor likes yours too. Okay, here we go. Let's check this out. Ready? 3 times 3 is 9. Do I need to do any others? Why not? Because it's zeros. Okay, how many decimal places? 2. So 1, 2. And then times it by 0.3 again. So this becomes 27. How many decimal places? 1, 2, 3. Does that make sense? So 0.027. Okay, 2 times 5.2. I'll even make that brackets for you. Do you like it when I make it brackets? Is that better than all the parentheses? Okay, what comes next? Multiply. 2 times 5.2 is what? 10.4. So we get 10.4 plus 0.027. 3, 4 squared plus. Okay. When we add 10.4 plus 0.027, line up your decimals. 10.4 plus 0.027. What will we get? Plus 10.427. So far, so good? Everybody okay? Now where? I'm done with the grouping. Exponents. 4 squared. 16. Then what? 3 times 16, which is? 48. And then when we add 48 plus 10.427, we get 58.427. And again, I haven't given you any instructions to round, so I would just leave it even if it's a couple places. Okay? Are you okay? I know this is a lot of review. Can you line up decimals when you add or subtract? Yes. How many of you, this is a little bit faster paced than you're used to? Just a little? Okay. You'll get used to it. Like as far as like us just rolling and keep on going, I promise you, you'll get used to it. Okay? But everybody's okay. You can line up decimals. You can multiply decimals and move them decimal places. You've got the order of operation as to what comes next. Speak now, forever hold your peace. You know what my pet peeve is? For me to teach a lesson and everybody to say, no questions. And then I give you something graded and the whole class bombs it. So obviously you had questions, you just didn't ask. So when's a good time to ask questions? Now. And most likely, if you ask me, one time I taught a class for like 2 weeks. They said, no question, no question. And finally, someone said, okay, Miss Collins, you have just got to blah, 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 blah. And the whole class went, phew, I'm so glad you said that because I'm lost too. So most likely, if You have questions, someone else has the same question. So make sure you ask. You don't. And we're going to actually cover this, okay? There are times here, and we're going to actually talk about this in just a minute. There are times, like I told you, when you plug in, you need to plug in with parentheses. So this was the first one, so I just used parentheses on all of them. This one you got to have. Why? And it's got other stuff with it. This one you got to have because it's got other stuff with it. This one you don't really have to have because it's pretty much by itself. Does that make sense? So when it's got other stuff with it, you got to have the parentheses. And when it's kind of by itself, you don't really need the parentheses, okay? But if it makes you feel better to put the parentheses there, like you don't understand like when to put them and not when not to put them, okay? But Faith, obviously you know when to put them and when not to put them, so you don't have to put them there, okay? So let's talk about that one on this one. How many are up for a problem for candy? So why don't you try this one? When you get it right, raise your hand. If you get it right, I'll come by and give you some candy. Okay? I'll give it till I'm out. How about that? I always just go get a handful. Okay? I will tell you this, though. You only get one shot at candy. So if you raise your hand and you go quickly and you make a careless error, you just wasted your one shot at candy. Does that make sense? You only get one shot at it. So it better be right. Is this a fraction problem or is this a decimal problem? How do you know it's a fraction one? So I'm going to tell you right now, I do not want you to take that 3/4 and make it 0.75 and work it. I want you to leave it 3/4 and work it as a fraction. I'll go back to this in just a second. All right, here we go. When we plug in, here's the question. Do I need to put parentheses around the 2? No, because the A is all the way out here by itself, right? And so if it's kind of by itself, you don't necessarily need the parentheses. So Faith said, when do you put parentheses, when do you not put parentheses? Okay, here's what we're discussing. So how about the B? Does it need parentheses? Yes. Okay, so I'm going to put 3/4 in here, plus 5, divided by, does the C need parentheses? No. Okay, so inside the parentheses, 3 becomes what? 3/1 times 3/4. Do I need common denominators? No, so just multiply across. Don't forget to look to ever see if you can cross reduce. Like, can the 3 and the 4 reduce? No. Can the 3 and the 1 reduce? No, but always look, just in case. Okay, so this becomes what? 9/4. Everybody with me so far? How many got that far? Okay. Now, let's add 9/4 plus 5/1. What do we know about adding fractions? You must have common denominators. What's our common denominator going to be? 4. So what do you know about this one? Stays the same. How did I go from 1 to 4? Times by 4. So times by 4 here. And I get 20. So now this becomes 29/4. Again, the denominator stays the same. If you went to that much trouble to find the common denominator, leave it. Okay, it stays the same. So now we can square this too. So what I'm going to encourage you to do is to always look at your problem. How many of you get going in your problem? And like how many of you took 4 and you actually multiplied it by 29 and you got 116 and da 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 da, and then you turn around and divide it? Look, always keep your eyes open and look for shortcuts, okay? Garrett, do you see a shortcut? What is it? Okay, which 2 4s? These 2 4s or those 2 4s? These ones right here. Because look what it says. You take 29/4 and you times it by 4, and then what are we going to turn around and do? We're going to do the opposite. And so if I take 2 steps forward and I take 2 steps backward, what am I going to end up with? The same thing. So if I take 29 over 4 and times it by 4, and then turn around and divide it by 4, what are you going to end up with? 29 over 4. There's your answer right there. How many of you right now are going, oh, I did all that work for nothing? Garrett, do you want this or not? Whoops. This is why I don't play sports. All right, there you go. You could, if you wanted to keep rolling, you could 4 over 1 times 29 over 4. What would I have told you? Those that multiplied straight across, just a reminder, what would I have done if I would have multiplied this? What can I do with this 4? It can become a, and this can become a, so I would have just made 29 divided by 4, and what's a better way to write this? So here comes more middle school, high school math. This little division symbol is more like middle school math. How do we write divide in high school? As a fraction. So wouldn't this be the same thing? So I would rather you just, anytime you have that divide symbol, I'd rather you just take it and make it a fraction. Okay? Because Miss Corns loves fractions. Okay? All right. You want to try another one for Candy?
Yes.
Yes. All right. Here's the last example. You can redeem yourself. All right. Is this a fraction problem? Is this a decimal problem? And I'm going to tell you this right here. What would I do right off the bat, right here? I'd take this and do what with it? I'd make it a fraction. I wouldn't do the dividing. I wouldn't do long division. Everybody says, really? How many do not like long division? Yeah. So I'd just make it a fraction. Okay? All right. See what you can do. I got 1, 2, 3, 4, 5, 6 pieces left. Let's finish this up. What's the answer? 3. All right, here we go. It is 3. Do I need parentheses here? No, why not? Because it's by itself. Okay. Do I need parentheses here? Yes, 1/2. Do I need parentheses here? No. And again, the first thing that I would do is take that, because this means long division. I'd have to divide 2 into 5, and it will become a decimal, and blah. I like fractions. I just go ahead and make this 5 over 2, okay, instead of 5 divided by 2. This does the same thing, okay? So I'm going to multiply first. 5 times 1/2. 5 over 1 times 1 over 2 becomes 5 over 2. Do I add first? Do I subtract first? Subtract. So 3 over 1 minus 5 over 2. We must find common denominators. Nobody does that with me. It's so much fun to do. Here we go. This is going to stay the same. This becomes a 2. So how do I do this? Times by 2. How many have issues finding common denominators and getting it right? Anybody? So if that's something that happens, I recommend you write times by 2, times by 2. It makes a world of difference when you write what you're actually timesing by down. How many actually write what you're timesing by down? Does anybody? So I have a couple that do that. So 6 minus 5 is 1 over 2. 1/2. Okay?
Can you just do like Garrett said last time and just cancel off the 2 5 over 2s?
You could. Very good. We'll go there. When you add these together, 1 plus 5 is 6 over 2. And when you simplify 6 over 2, you get 3 over 1 or just 3. I will take 3. I will take 3 over 1. Okay, 3 is better. But 3 over 1, I will not take 6 over 2. Okay, I'll take off points. Everybody understand that because it's not simplified. On the SOL, will you have 6 over 2? as an answer choice? No, you'll have 3. Okay, so make sure it is simplified. And I do agree. Seth said, can you just take these two right here, negative 5 halves and positive 5 halves, and just cancel them out and you get 3? Could you do that? Absolutely. Very good shortcut. Okay. Exactly. Exactly. I really need, anybody ever happen to see one of these? I'll even pay you back for it. I used to have an easy button that I loved, like from Staples. You with me? And I had a student that brought me one time that said, she's like, you can have this, because I always talked about it. But I always talk about like making math easy. And I'm hoping that some of these techniques that I've showed you today, you may or may not think that they're easy or hard. But like I think making it 5/2 and just dealing with it as a fraction is a lot easier than having to set up a long division problem and making it. Gotcha. Right. No, you can just make it like a fraction, and then all you have is subtraction and addition. Because I think that's easier. I mean, I guess you could sit there and do the long division and divide first, but I find this easier. Okay, so what we're going to do, we're not going to do that practice work. Let me save.